Now think it through.
Uh, Over here, our H naught is our threshold frequency, right?
F naught is threshold frequency.
Okay, so we know that the threshold frequency of A is
Mhm.
lesser than that of B,
Okay.
right?
Where is it? Well,
So because electromagnetic radiation of frequency Fa less than, sorry, Fv just managed to produce a non-zero
mhm.
photocurrent. So from that, we know that it's probably the threshold frequency, right?
Correct. So when they say just manage, what does that mean? To what will change in the equation if it is just managing? Okay. See, when they say just about managing, that means the kinetic energy of the electron is what?
Negligible.
Uh-huh.
Zero?
It is zero. Just managing means electron has just come out. It does not have any kinetic energy.
Yes, sir. That's why the FA and FB would be the threshold frequencies, right?
Fa and Fb. Okay, close enough. But see, in the question they have said Fb is greater than Fa, isn't it?
Yeah.
Okay, so wait. Let's say, see, we are having two different metals, A and B. So, Anishka, will the threshold frequency be the same or different?
No, no. For A it would be FA and for B it would be FB because in both cases it's just managing to produce a non-zero
Correct.
photocurrent.
So, in the second case, okay, see, for plate A, the equation is clear. For plate B, and Anishka, only looking at the first statement, what will be the equation for plate B?
HFB is equal to HF naught for
No,
plate B.
look at the question again. The electromagnetic radiation is having frequency of Fa. This is incident.
Oh,
It will
okay.
be H into Fa only. Now what? It will be HF naught B plus kinetic energy. Again, it is just managing.
Easy.
Okay, now think it through. This is in fact tricky. But
So it
Anishka, your
is
overall,
C
no, no.
because if you put your kinetic
I still think
energy
it's
is
B
zero,
only.
The answer
then
is
you
B
need
only.
HFA.
Listen, the answer is in the MS is option B, but we need to get why.
So I thought it was because since FA is smaller than FB, the
FB.
difference between F and FA, or rather HF and HFA, would be a lot greater.
Okay.
Which
Fine.
is why I had a question about, sir, if they're saying FA for both the plates, why are they saying frequencies?
Why the same frequency?
Frequencies, because it says that electromagnetic radiation of frequencies Fa lesser than Fb. They both hit metals A and B respectively, which means
Oh,
frequency Fa is
okay.
going on A and Fb
Yes,
on B.
yes, yes. So, Anushka, you are right. I missed that keyword. Yes, so the word respectively is important. So, electromagnetic radiation, Fa is on plate A. So, for plate B, Anushka, what will be the equation?
So then in that case it would be HFB is equal to HF naught of B.
Plus Ke, which is approximately 0. Right now, in the question, they have said Fa is less than Fb. So can we say the threshold frequency of A is lesser than the threshold frequency for B?
Yes, sir.
Okay, so far it's fine now. Moving on. When the radiation is having frequency of F, which is greater than FB, so what will the equation look like?
So then it would be HF is equal to HF naught plus EV naught. In case of
HF,
A, it will be,
HF
yeah,
naught A plus EV naught A, correct. And for the second plate,
the same but with B.
all right. So now threshold frequency for A is lesser. That's it. So we are done, correct. So now just compare the two equations and this. You will be able to deduce that V naught for A is greater than V naught for B. Oh, finally, yes. So check all of you, all the steps. Ahan, check. Does this make sense now?
Yes, sir.
Christine, check the steps.
I got it, sir. So basically, the stopping potential over here is depending on the amount of kinetic energy that each do, and since B would have a lesser kinetic energy, um,
Mm-hmm.
therefore the stopping potential of A would be greater, right?
Yes, 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 correct. So yes, Anishka, basically the respectively word was the keyword here, which we had missed. I had missed. So Ahan, the option which you had rejected is the final answer, B.
Yes, sir.
All right, so moving ahead. All right, next question. Try this.
So does it uh, intercept X?
So which means option A. Can you explain the logic? That is correct.
So because work function is energy and y-axis is given as electron volt,
Mm-hmm.
which again energy, and gradient would give us Planck's constant, right?
Correct. Good.
Technically, yeah.
Remember where all of this is coming from. Y gradient is H,
So the basic formula. I've like
which is,
I remember it, but I
array, we
I
just
don't
did it.
remember it. But
We just did it. HF is HF naught plus kinetic energy. So kinetic energy is your y-axis. So make kinetic energy as the subject. And then we just do y is equal to mx plus c. So you can see gradient is h and the y-intercept is negative of the work function, which is intercept x. This is from the class notes. So Anishka and Kushni, check. Is it clear?
Yes, sir.
Yes, sir.
Okay, moving on. Next question. Please try this.
Sir, D.
2 to 3 and 3 to 4. Explain.
Sir, they're the only transitions with a difference of less than 2 electron volts.
So 2